Hey viewers, welcome to episode number 10 of my Matlab Programming course. We're not going to continue on our previous example. So not the same program that we did last time, because I wanted to give you a little more of time to react to that, which is fine if you don't react to it, because I will continue it eventually. Today we are building a clock, a digital clock, and we are using a switch loop to do so. The switch loop is kind of more of a switch statement, just like the if loop is more of an if statement, but I like the word loop. I will show you what it looks like, so kind of the reverse engineering, I guess. This is what I want it to look like. Well, I already built it, so I know it's going to look like this. And as you can see, it has hours, minutes, and, well, just the seconds. And we only see the seconds for now. So we're going to see how to build this. Basically the black and red clock, and then I will show you how to bring in a background, how to edit the background, and basically everything that you could possibly want from this. So it's completely modular. That is my thing. I always build things as modular as possible, which means that you can take one bit, alter it, and it will not affect the rest. The thing is, if you make something modular, you can also add modules or remove modules without affecting the rest of the program. So it's a really valuable thing to learn. And even though I'm not going to explain a lot, you will see it come. You will see what it does, basically. So we're going to state some things first. First of all, we're going to do the CLC clear close all. That's the standard thing by now. You should know what it means. By the way, we have all kinds of variables here, so you can see that clear will actually just remove all of that. And CLC, of course, clears our command window. You should know that by now, and close all figures, because we do use a figure. So our maximum amount of hours on the clock is 23, because 24 is 0 again. Then 59, same thing, you never hit the 60, you have 59 as the last, and then you switch or you go back to 0. Same for the seconds, of course. Then running is true. It's kind of a useless statement, but you can actually say make it count backwards, for example. And if you let it count backwards, then you can set running to false at the moment it's supposed to stop, and then it will stop. Otherwise it will, well, continue to minus in principle. But, well, for now, we're not too concerned with that. For now, it's just a random statement. Maybe we will we will do more with this in a later stage, in a future episode. So we are going to say the current time is 0 hours, 0 minutes, and minus 1 second, because I wanted to start at 000, and it basically, the first thing it does, as you can see, is it adds 1 second. So the first thing it actually does is we have a while loop here, because we want it to run indefinitely until we say it has to stop. Currently, there is no stop. The only way to stop it now is Control-C, which breaks the entire program, whatever the program is, and wherever the program is. So first of all, we're going to pause for 1 second, and pausing for 1 second means that every second we're going to execute this, and then it's going to wait 1 second. It does mean that it doesn't actually run on time, because it does not have an actual internal clock. It just runs the entire script, then pauses for 1 second, runs the entire script, pauses for 1 second. But that means that the length of the script is not incorporated here. You can do that. There is a way to get the time in here. I'm not going to explain that to you right now, because we just want to build a clock for now. And as I said, maybe I'll do a future episode to show you how a proper clock should work. And well, that's basically all that I have to say about that. Second is second plus 1. As I said, you add 1 second to the clock, because that is kind of how it works. Then we're going to convert the seconds into seconds, minutes, hours. Basically, if seconds is bigger than the maximum amount of seconds allowed on the clock, we're going to add a minute. So minute is minute plus 1, and we're going to subtract 60 seconds, which means that, well, the only way to be bigger than second max is if it's 60 or higher. So the minimum is 60, so if I do minus 60, the minimum is 0. So it will actually come to 0, and the minutes, of course, well, they can count upwards, it doesn't matter. So we're going to do exactly the same for the minutes then. So if minute is bigger than minute max, then we're going to subtract 60, because then we're back to 0, and we're going to add an hour. And then, of course, if the hours are more than hour max, we're just going to subtract 24. The thing is, you want to do this in the beginning, because it is your main clock. This is your actual clock, so you go from here. And now you split your initial count, the seconds, in different stages. But keep in mind, we didn't actually do anything else than just split it into, well, different parts, but we keep the seconds as our counter. So these are all variables that need to be remembered through the entire program. Also keep that in mind, because if I edit the hours or the minutes in, well, future text, then my clock is off. My clock doesn't work the way it's supposed to. So we're going to split then both all three of the numbers in two numbers. So the seconds, if you have 0 to 9, that's your first number, then, or rather your last number, and that's on that side for you guys. Then you have your 10, 20, 30, 40, 50 as your second number. So your first number, or your last number, can basically be 0 through 9. Your first number can be, well, in the case of hours, 0, 1, and 2. In case of minutes and seconds, it can be 0 through 5. So we have to split those, because we're going to build them up with the little segments that you see on digital clocks. So you can, of course, just make a whole, how do you call those? Yeah, little picture of the entire number and just put that in there, but that's not how we do that. We don't do this to make a clock. We do this to learn how the process works. So how do I construct a number from, well, separate segments? And as you can see, we're saying second first, second last. So we're going to add or edit the second first. First of all, what we're doing is, this is our first number. So the number on the seconds. So it's the 10, 20, 30, 50, 40, 50. The second last, you can also name them differently, of course, is our last number. So that's 0 through 9. So the first 10 seconds, basically, the second first is 0 and second last is the actual number, and then it starts to deviate from that. So we have another while loop. So inside the while loop, we have another while loop. And this while loop is going to say if our last second, so basically our number, is bigger than 10, then we're going to subtract 10. And we're going to add 1 to the first number. And of course, well, the same goes for the minutes, and the same goes for the hours. So it should be pretty easy to understand what's happening here. We split the seconds into minutes and hours, and now we're splitting the double numbers into single numbers. So I now have 6 digits, and we're going to go with that. Well, what we're doing now is, this is where our switch comes in, a switch statement, because we are going to find how the number is constructed. Basically, if you have a 1, you have 7 blocks to make that 1. So 7 segments on a digital clock. We only wanted to write ones to be on. So those two are on, all the rest is off. But to do that, we made a separate loop. It's in find number, and well, we basically give it the number that we want it to represent, which is 0 through 9. And for us, it doesn't matter where the number is or why you want to know this. We just want to give it back whether the light or the segment should be there or should not be there. So whether the light's on or off, basically. So in this case, it's top right, bottom, bottom left, top, and middle. And they're either true or false. So as you will see, for 8, everything is true. For 1, only the right side is true, the rest is false. You can, of course, make your own numbers. If you don't want to use this, but you want to use another system, I don't know, you can do this, because there are actually way more efficient ways to build clocks than to have the time on it like we do. But yeah, you can make whatever you want out of this. I used it as a normal digital clock, just to, well, make that. By the way, I did give it, so switch, you put your variable here, and then you're going to, or well, whatever you want to have. You can also do number squared or number plus 4 or whatever. And then you go with cases. And the case is if it's 0. It's basically a shorter way of an if loop this. But it works exactly the same. So then it gets all these variables, and then all these values, I should say, true or false. And then we have otherwise. And otherwise, if the number is none of these cases. So if it's basically lower than 0 or higher than 9, or yeah, like 9.3 or 0.5 or 5.2. Then it's going to generate an error, because generate error doesn't actually exist, as I can show you. Because if I actually execute generate error, it's going to say, well, error. Wow, mystery there. Then we're going to make the output vector, and the output vector is just a vector of all of these guys together. And the output vector is put over here, and that one is fed back here. And it's stored in output 1. And then, well, that output 1 is our rightmost number. Then output 2 is our second number from the right. Then output 3, the third number, and so on until number 6, which is the tens of the hour, I guess. So here I put a reminder for myself what the output is, because I do have outputs, and what the output is only in this other file. So there's a second file that actually states what the output is. Here it is. And I just copy pasted that into this one, just to make sure that I remembered what is what. So place 1 is top right, place 3 is bottom, place 6 is top. If I need that, I can look it up now. What we're now going to do is load in the 2 things we need to make a clock. The segment, that is the main thing. That's the little stripy thing. I can actually show this to you. Yeah, figure 1. Let's take 2. In show pixels. And we can do the same for dots, only figure number 3, and pixels 2. So let's run this, and I can show you what they look like. That was really quick. So this is number 1. It is just a line with 2, well, triangles on it. And the other one is just 2 dots. Both of them are the same size. It's not necessary, it just made it easier for me. But they are both the same size, and well, we use that fact by, well, so that I don't have to calculate too much on where they need to go. But for the rest, it doesn't matter. It really doesn't matter. You can make them any size, and well, it will be fine. Anyway, we're going to find the number of rows and number of columns in pixels. So that's the original, that's the segment, because we need to be able to get the segment into our picture. So we need to know how big it is, because otherwise we can't position it. And we want to be able to rotate it so that we can also make the horizontal lines, because as you saw, it is a vertical line for now. And of course, that all depends on how you draw it. You can also make a horizontal line and then just rotate it if you want to have a vertical line. It's the same thing. So what we're doing here is we're adding to both of these, we're adding one row and one column of zeros. So basically we have the matrix and we want to add a row in the end and a column in the end to, that's on this side for you guys, to make sure that the program doesn't run into an error in one of the future things, because I'm going to have to use that. So you can do it by programming it differently. I just edited the segment because a row of zeros means there's nothing there. So I can add as many zeros as I want, and it won't affect the thing because it kind of calculates from top left. So whatever I add to the right, as long as it's zeros, or to the bottom, it doesn't matter. So why top then? That's our position, well, vertically. And of the top segments, then top, right, and left. That's the two segments on the sides, but top side. Then the middle, that's of course the horizontal thing in the middle. Bottom, left, and right, that's the two side things, but then the bottom ones. And Y bottom is the, well, vertical position of the bottom part of my my clock, the bottom segment. And then of course we have the X position as well. We have left, middle, and right. The left is, well, the left. The middle is all of the horizontal lines. The right is of course the right side. So those are verticals once again. And then we're going to take background pixels. Background pixels is just our frame to, well, encompass our clock. In this case, it's 720 by 1280 by 3, which is 720 high, that's the number of rows, 1280 wide, that's the number of columns, and then the number of colors, and we have 3. So as you can see, I commented out 2 things. I will show them later to you. This is how you add a background, because this is actually your background, which is why it's called background pixels. Wow. I like to give my variables names that I can actually understand if I view this program 2 months later, because then, BG is background, it always is in my programs, and then pixels, that's kind of obvious what that is, so should be obvious. Now for number 1 through 6, as you can see, we're going to do a for loop, and it's quite a big for loop. It ends here. Actually, is this the one, or is, this should be the one. It ends in line 155, and that is indeed this one. So for number 1 through 6, that is which number we have on the clock. So basically 1 is your rightmost number, then 2, 3, 4, 5, 6, and 6 is your first number. So if number is 1, then output is output 1. I had a very nice statement here, but it was too complex to show you to still understand. Remember that we output which things were on and which things were off. Well, we do need those now. So I made an else if statement to get the right output. So basically this is which variables are on, which variables are off. And I'm going to now draw them in. So if they're on, I'm going to draw them in. If they're off, I'm going to not draw them in. So we're going to do that for all 6 of the numbers. And we're going to take an output. It doesn't matter which one we take. And then we're going to take an X correction, which we will see later why. But X correction basically moves, as you can see, if it's bigger than 2, so that's 3, 4, 5, and 6, it will move those 25 extra to the left. That's that side for you guys. So it will take the first two numbers and then make a little bit bigger gap and then take the next two numbers, or next four numbers in this case. But as you can see here, if it's bigger than 4, we're going to have the correction minus 50. So it's going to make a gap of minus 25 between the the second, third, and fourth and third and fourth and fifth and sixth. So we have two numbers, big space, two numbers, big space, two numbers. And if you calculate all of that, you get that you should start at 1280 minus 252, because you're going to have 253 remaining on the front end then. So your clock is nice and centered in your thing. So this number is actually based on the fact that I'm using 1280 here. Of course, you can make this a little more flexible by actually putting the calculation in here, and that way you don't have to put an actual number in there. But I just wanted to show you that it is the number that make sure that our clock is centered in the middle. And as I said, you should do this by formula. You should put the formula in there so that if I make a background which has, I don't know, 2000 pixels, it should still be centered. Now it's not centered. So yeah, kind of messy. But I know I shouldn't do this like this, but I think the program is complex enough. Then we're going to take the number. That's which number we're working on. And we do -1 times 125 because each number has 125 space to the next number. So basically that's the number itself plus the little gap between the numbers, and then plus the X correction, because if the number is, well, we want to group them by 2 and then put a bigger space in between them. That's why there's the X correction. And then we do that for all of them. Obviously, they all have a unique X position, they have a unique Y position, and for those of you who really are paying attention, here it says Y position with the formula for X position, and that's the same over here with this one and with this one. Those are the horizontal stripes, and that is because we are going to switch row and column to rotate them without actually having to rotate the picture or needing a second picture. So yeah, this basically, so this whole part basically states where our top left pixel should go. It's as easy as that, really. It looks really complex, but it really isn't. It does that for every one of the segments. And then we're going to say we need to know more about the segment, so we're going to make another switch segment. In this case, 1, 2, 4, and 5, those are the vertical lines. They should be printed like this. So if it says true in the output, because, well, we had an output, and if it's true, the segment, then it needs to be plotted. Otherwise, it doesn't need to be plotted, so you can skip this whole part. If it's true, then we're going to fill in all of the row and columns one by one. Well, that's pixels one by one. But to plot something, it needs to be red, because if it's not red, then it's black, and we don't want to print a black. We want to print a red, because remember that we added those zeros on the end. So the last row, that's this side, the last row and the last column should not be printed. Or even if I did more than that, I don't want to print all those black things, because they're going to print over the red, and I want the red to be there but the rest not. And especially if I add a background, because if I add a background and I'm going to plot black crap over it, why would I use a background? It doesn't look good. So I only want it plotted if there's an actual color in there. Of course, here you should watch out, because if you change your color from, I don't know, red, I currently have red, but if you want to have a green picture, this shouldn't be 100, because now it says if red is bigger than 100. And yeah, you don't want that, obviously, if you have a different color. You need to make a different statement here to make sure that you catch whether or not it's black. And obviously you can also say if it's not 0, which is like this. So as long as there is red in there, it should be fine. And yeah, I'm going to keep it like this, but because for now it works. But you need to think about where your program will go wrong if you change something. So this should be if red is 0 and or isn't 0, or blue isn't 0, or green isn't 0. So if one of them has a color, then it should be plotted. Otherwise, it should not be plotted. So as you can see, I'm just plotting in the pixels into the background pixels. So it will be a second layer on top of the old layer. So we have the background pixels. Those are all over the screen. And then we're going to put certain pixels in there that are overlapping the old pixels. So basically we print the clock on top of the background. It sounds really complex. It's really the way you do it always, because you make a background and then you put the foreground in front of that. And by putting it in front of it, you can no longer see the background, which is obvious. If you want to make a see-through clock, that can be done as well. But then you have to make a combination of the background and the foreground in this. So you have to say like 0.5 times the pixels plus 0.5 times the background pixels. That can be done, or whatever combination you want to make. Yeah, for now we're going to just assume this is correct. I will not really say why. I mean, you can see we're doing this for each row, which means that the pixels have rows, but the pixels do not have the big image. They're not the 720 by 1280. They're in fact 82 by 11, so they're really small. And therefore, the Y position and the X position need to be subtracted. And here's the +1. That's why we added that extra row and column to our picture, because of this +1. We need to do +1 because row minus Y position for the first, well, the first segment is 0. I mean, row is Y position, and then if we subtract them, it comes to 0. So we need to start at 1, and because of the +1, it actually runs to, yeah, I just realized I can also do -1 over here. That would work as well. And then I don't have to add the extra row and column, sorry. Then, if it's not 1, 2, 4, or 5, that means if the segment is a horizontal segment, then you do it like this. Basically, instead of row column, you now have column row, and that's all. So instead of plotting it like this, we're going to plot it like this. And it's really that easy. You just switch row and column, and you're done. Obviously, your initial position, so your Y position and X position that you set up over here, they need to be switched, because it thinks that the rows are the columns and the columns are the rows, so you need to switch them up. You need to switch them up everywhere. It's basically how you plot every segment, and then it's done. Then we want to add the dots. The dots are just 2 dots, and we want to plot them between number 2 and 3 and between number 4 and 5. So yeah, we just give them a position. The first dots are on the right side, so between 2 and 3. And these are between 4 and 5. You basically can just calculate where this is, and yeah, you should be fine. And then we're going to plot that in the same way that we plotted the vertical lines, because, well, it's 2 vertical dots. And then we're going to show it, figure 1, clear figure, show the pixels, and then this is just to allow me to get a breakpoint in there, because I did debug this. So if we then run it, you can see that it actually works. It's about 1 second. It's about 1.01 second, in fact. So every 100 seconds, it will add a second. Sorry, it will run 1 second behind. So it's not very good, but at least it shows the principle of how to make a clock. As I said, there are ways to actually synchronize the clock to your computer clock or to whatever clock you want. But that's really not what we care about here. So Control C to get rid of that. And let's see what it looks like if we actually, oh, I can just, never mind, I can just do it like this. If we run at full speed, you can see that it's actually not very fast. So the execution is not very fast. Every second it can execute it about 10 times. That's mainly because I'm plotting. So because of the pause that I removed, the plotting actually becomes well, the major bottleneck. If I have the pause, however, it has all the time in the world to plot. So it uses that pause to plot. And we will see that indeed the minutes work as well. And if we wait long enough, I can show you that. Huh? I didn't try it yet, but I'm assuming the hours work as well. We can just set the minutes to 59. And we can just run that. So this should work as well. There you go, 1 hour. And if we set the hours to 23, then that should work as well. So it should go to 000 here. Yes, it does. So it does work for the entire thing, which is excellent. And now we only have one thing left to do that I wanted to show you. As I said before, I commented 2 parts here. And the first is how to add a background. So instead of having zeros, which is just the color black. Oh, by the way, let me show you. I forgot to show that last time. If I do 255 times once, it actually becomes white. As you can see, there's a little bit of a black stripe running across this. That is because I'm using PNGs instead of JPEGs. But, well, whatever, it doesn't matter for you. Yeah, we're going to use a background, and yeah, I'll show you the background by just running the program. There's the background, and as you can see, the background is pretty much just the background. You can make whatever you want on that. You can also make an animation on the background if you want to. So let's show you a very simple animation. First of all, you can of course say that you want to edit the background before plotting the clock. So this is twice as bright as it was before, and we will now make an animation. The animation is based on seconds, so every second something happens. It's a very lame animation, it just darkens it, and as you can see, after 20 seconds it's gone. But it kind of adds a little bit of thing to it, because it reset now. That's why it resets every minute. So if you make it a minute long, then you can actually I think that's like this. If you make it a minute long, it will actually reset every minute. You can also make it 2 minutes to let it fade and then come back up again or something like that. But here you can see it actually works. If you run it for a minute, then it will come back up. And yeah, you can also make it 24 hours. You can make it however long you want. I mean, it's all up to you. So this is a very easy way to make a clock. Well, it's not the easiest way, obviously, because we did it in a very modular way, which is not normally the easiest way to do it, but it is the best way to do it, because as you see, I can just take out the background, replace it by something else. I can also take out the hours if I want to and replace it by something else. I can do whatever I want to the program, basically. Add things, subtract things. It will still keep running. It will still keep doing what it needs to do. If you make it like the easiest possible way, then it's completely inflexible. This is completely flexible, which is the way you should be programming in the first place. But anyway, yeah, that's all I have to say about it. Hope you learned something today, and I will see you next time.